Hello everybody, today we're going to talk about adjacent and vertical angles. Okay, so we're going to classify some angles first though. So an acute angle is an angle that is less than 90 degrees. So it's very sharp. Acute means sharp. This can be anywhere from 0.1 degrees up to 89.99 degrees. It's just got to be less than 90. Okay, that's an acute angle. A right angle is an angle that is exactly equal to 90 degrees, and you will see you'll see a little square corner in here. That indicates that it's a 90-degree angle. An obtuse angle is an angle with a measure that is greater than 90 degrees. So anything bigger than 90 up to 180 degrees. And then a straight angle is an angle that's exactly equal to 180 degrees, and basically that's just a straight line. Okay, so there's your 4 classifications of angles by their measure. Okay, adjacent angles. Adjacent angles are angles that share a side and have the same vertex. You have to do both. So if you look here, these 2 angles right here, we'll call this angle 1 and this angle 2. Those angles are adjacent. They share this side right here, okay, and they share this vertex right there. So they're adjacent angles. Okay, these 2 angles, we'll call this one angle 3 and angle 4. They are not adjacent angles. They do share a side, well, part of a side anyway. They don't share this part, but they don't share a common vertex. And then these 2 angles right here, angle 1 and angle 2 in this picture, they are not adjacent. They do share a vertex right here, but they don't share a side. Okay, angle 2 has this side and this side, angle 1 has this side and this side. They don't share a side, so they are not adjacent. Okay, vertical angles. Vertical angles are formed by 2 intersecting lines, and they do not share a side. So angle 1 and angle 3, those are vertical angles. Angle 2 and angle 4 are also vertical angles. You will always get, when you have 2 lines intersect each other like this, you will always get 2 pairs of vertical angles. Those 2 will be vertical, and those 2 will be vertical. Okay? All right, how to name an angle. This is important. There's several ways you can do it. You can use it, you can do it using numbers. Sorry, went brain dead there for a second. So we've got this figure right here. And just like I did in the last pictures, here's angle 1, that's this angle. Here's angle 2, here's angle 3, here's angle 4. Okay? So I can do them that way. Sometimes it's not convenient to do it that way. Okay, now here, if I just got a single angle by itself, I can name it using the letter of its vertex. So here's angle A, because it's obvious what we're talking about right here. Here's angle A, here's angle B. Okay, in some cases you got to use 3 letters though. Okay, so here's the way you do it. This could be called angle XYZ. It could also be called angle ZYX. And this one stands alone, so you could actually just call it angle Y if you wanted to. Or, you know, alternatively, you could throw a number in here and say, oh, put a 2 in there and call it angle 2. But it's pretty flexible because I have just an angle by itself. Now, notice I didn't call it angle YXZ. So the vertex is always the middle letter. Always. Doesn't matter which way you go. You can call it ZYX, you can call it XYZ. It does not matter. Okay? But the Y has to be in the middle. Now, over here, this is where you really have to use 3 letters. Or you can put in numbers in some cases, but not always. So, here I've got 3 different angles that share the same letters. Okay, so I have angle JKL. That indicates that is that angle right there, and only that angle right there. Angle LKM, that would be this angle right here. Now here's the other thing that you can get is angle JKM. Okay, JKM is that angle right there. Okay, so when I have a complicated picture like this, I need to use 3 letters. Now, I could have used numbers on a couple of these. I could have said, oh, this is angle 1 and this is angle 2. But if I want this angle right here, the big angle, I can't use a number on that. I have to use letters. That's JKM. That's what I'm going to call it. That's what I have to call it. Or I can call it MKJ. Either way, you understand what it is I'm talking about. We do this so that everybody knows exactly what angle. There's no ambiguity about what angle we're talking about. Okay, so name a pair of adjacent angles. Now there's a whole bunch of different adjacent angles here. But some examples, you could have angle ABF. That would be this angle. And an adjacent angle to that would be angle FBE. So there's one pair. So they're adjacent, they share a vertex, they share a side. Okay? Now I could also have angle FBE, and so that would be this angle right here. I could have angle EBD. Whoops. That would be these two angles. I could have, forget this angle here, I could have angle EBD and this angle DBC. You can see I'm kind of working my way around here. I could have angle, whoops. I could have angle DBC and angle CBA. And then there's one more that I could do if I ignore this one. I can do these two, so that would be angle CBA. Oh, that looks ugly. And angle ABF. So basically I worked my way counterclockwise around this thing until I got back where I started. So there's 5 possible answers to this. Now if I want to name a pair of vertical angles, there's not quite so many options here. There's only one option, in fact, and that would be angle ABF, and so that's this angle right here, and then this angle right here would be angle DBC. Those are the only two that are formed by 2 intersecting straight lines. Okay? Tell whether the angles are adjacent or vertical, and then find the value of x. And it looks like I left those off of here. So, let's see. Hang on one second. Okay, so sorry about that. I had these on the wrong page of the notes, so I just had to find them. Okay, so tell whether these are adjacent or vertical and find the value of x. Okay, so this is really easy. Here we've got these 2 angles, x and 70. Those are definitely vertical angles. And Luna the math cat has decided to show up, put her comments in. So, now, here's the thing that we know, or we should be able to figure out on this, that x is going to be 70 degrees right here. Okay, so Why is it 70 degrees? Well, if you think about it, these two angles right here are going to add up to 180 degrees because they form a straight line right there. Okay, so let's start with these two angles right here. These two angles add up to 180 degrees. One of them is 70. That means this one has to be 110 degrees. Okay, now the next two, these two angles also form a straight line. So they have to add up to 180 degrees, which means if this one's 110, that one has to be 70. And likewise with these, this one ends up being 110. Okay, so these two angles are 70, these two angles are 110, which is going to bring us to a theorem on the next page. Okay, now notice this. These two angles right here are adjacent. Okay, they share a side and they share a vertex. So here's the vertex, here's the side that they share, and they add up to 90. So here's what I know. I know that x plus 4 plus 31 has to equal 90. And so I can figure out what x is because I can combine my like terms here. X plus 35 is 90. I can subtract 35 from both sides, and I'm going to get x is 55 degrees. Okay, and so I know this is 55, and that makes this angle right here 59 degrees. 59 and 31 adds up to 90. So these are adjacent, and x is 55, and the angle right there is 59 that's missing. Okay, now here's the theorem that you're going to get, and you should know this till you die. Right here. Okay, so vertical angles are always equal. Say that to yourself. Vertical angles are always equal. So if we look back here at this, here I have vertical angles, they're equal. Here I have vertical angles, they're equal. That is always going to be the case because anytime I have this situation where the two lines intersect each other, okay, this angle plus that angle is going to add up to 180 because this is a straight angle right here. These two angles also have to add up to 180. Okay, if x plus y is equal to 180 and this is y, then that has to be x again. And likewise, this has to be y again. And so you can see these are equal and those are equal, and that's always the case. Another term here, complementary angles. Complementary angles are any two angles that add up to 90 degrees. Okay, you need to know that as well. In fact, if we look here, these two angles added up to 90 degrees. This angle and this angle are complementary to each other. And then supplementary angles are any two angles that add up to 180. So if I look in this picture right here, these two angles are supplementary because they form a straight angle, they add up to 180. Same with these two, same with these two, same with those two. Okay? Anytime you see a picture like this, those two angles will be supplementary. Okay, this right here is a protractor. It measures angles. You're going to notice it has two scales. It's got a scale on the outside that goes from 0 up to 180 over here. It's got a scale on the inside that goes from 0 to 180 over here. Okay, the reason it has two scales is so that you can measure an angle from either side. Okay, now this line right here, I wanted that to be a different color, is called the baseline. Okay, and I just kind of highlighted, but I'm going to take it off of here right now because I've got it marked right here. You can see this is the baseline right here. That is the side, or that is the line that you line up one of the sides of the angle with. Okay? this line has to always be on one of the sides of the angle. Now this point right here, that point right there, that is always placed on the vertex of an angle. Okay? So when you have an angle, here I have an angle, that point right there goes right there, and then I line up this line with one of the two sides of the angle. Okay? This is called the baseline. And then, now here's the thing. If you line up this side of the baseline, okay, with the side of the angle, then you use the inside scale of numbers, okay? Because you start at 0 and you work your way up. If I line up this side of the baseline with one of the angles, then I use the outside set of numbers and I use the outside scale. And it should be obvious to you anyway when you get an answer, even if you weren't sure. Like, let's say my angle ended up right here. Okay, and of course I covered up that number. So if you were confused, is it 110 degrees or is it 70 degrees? Well, is the angle acute or is it obtuse? If it's obtuse, that would be the 110 degrees. If it's acute, that would be the 70 degrees. Okay, the only one that should be slightly hard to tell might be if you were at 89 or 91 degrees. Okay, so measure the two angles below. So notice that I've taken my protractor, I put that little dot right there on the vertex of the angle. I've lined up this side with the baseline, and now I measure the angle. So here's my 0. I've started 0 and I work my way up. 10, 20, 30, 45. This is a 45 degree angle right there. Okay, now this one over here, notice again, that little mark, that little dot goes right there on the vertex. I've lined up this side of the angle, so I'm going to start at 0. I always start at 0. I don't want to start at 180, I want to start at 0. And I count 10, 20, 30, 40, 50, 60, 70, 80, 90, 110, 120, 121, 122 degrees. This is a 122 degree angle right there. Okay? Let's make these a little more standout-ish. Okay. So you get to do these problems. So find out what x is here, find out what x is here, find out what x is here. So pause the video, and then jump back on and compare with what you've got. Oh, and by the way, this one should have that right there in the corner. All right, there you go. You're off. Okay, these two angles, they form a straight line, so they add up to 180. So x plus 85 adds up to 180. So I'm going to go ahead and subtract 85 from both sides of this. And I'm going to get x equals, what is that, 95? Okay, so this is going to be a 95 degree angle. That's slightly obtuse. This is slightly acute, so that's slightly bigger than 90. That one's slightly less than 90. Okay, over here on this one, these are vertical angles. Remember, vertical angles are always equal, so that's a 90 degree angle. That means that has to be a 90 degree angle. Vertical angles are the best, because you always know what they are. Okay, then we got this one. So I know these two angles add up to 90. They're complementary. So 2x minus 2 plus 68 has to equal 90 degrees. Okay, so I can combine my like terms here. So 2x plus 66 equals 90. So I can subtract 66 now from both sides. So 2x is 24. And so x is 12. Okay, so I know this is 12. And that tells me what the angle is. Now I already kind of know what the angle is because I know that these are 90 and that's 68. So this has to be 22 degrees. Okay, so if I put 12 in here, 2 times 12 is 24, minus 2 is 22. It all works out. Okay. So you're going to get to do problems 1 through 29, the odd ones in class. I will see you guys later.